Hello guys, today I want to talk about the sinusoidal motion profile. This one is much more manageable compared to the previous profile that we talked. In the previous profile, I was talking about the S-curve and the snap, this kind of thing. So this one also is used in the industry, although I'm not using it personally. I have done this one before, so this is not one of those motion profiles that it is I have not done. Okay, but this is not something common among I would say that among control engineers we choose this one less over others. However, the mechanical engineers, they love this one. Later I will explain why mechanical engineers love this. So first of all, how is the equation? Actually, the equation for this one is very manageable. Okay. So they have bunch of equations. So for example, you just put in your position and this kind of things, and he basically form for you a sine wave. So it means that, for example, when you do the acceleration, he do, for example, sine wave, and when you do the deceleration, he do the other sine wave. Okay. So in this one, it shows the thing better. Okay. So in literally what you do is that you just, for example, you put that, for example, how much is your position it is. Okay, for if you don't have a, for example, imagine, for example, you want to just do a triangle drive. So for example, you just, in the formula you just put your, if not mistaken, so don't go with your, but for example, you, for if especially if you don't have a constant velocity, you just put your position, the amount of the position that you want to travel, and based on that one, he just form a sine wave for you, doing that. He doesn't care about that how much is jerk or acceleration or something like that. He fit in the sine wave to that one. Okay. So if you do something like this, it means that you just put the position and you don't care about this kind of things. So the thing will come very simple, right? But what is the problem with this approach is that the issue with this approach, you have no control over your parameter. It's mean that if you just put the position in the sine wave and you let him to control, for example, you cannot to control jerk, you cannot control acceleration. He just form whatever he can. Okay, it means that he will just form, for example, the sine wave for you. So it is very simple and it would be very smooth, but no control over anything. Okay. However, so this one is very popular among the mechanical engineers. Okay, what they use it for? They use it for CAM system. So because the equations is simple, right? So why? Okay, so how they use it in a CAM? What does it mean? But they using it in a CAM system, it means that they integrate this entire thing to this entire profile to the mechanical structure. It means that, let me show you. Okay, so for example, imagine this one is a mechanical structure. The name of this mechanism, if not mistaken, is radial cam with a roller. Okay, so it looks like something like this. Okay, this one is a cam, so this one normally it will be attached to the motor or something like that. After that, this thing it will follow. So they will put a spring or something like that. So it will follow whatever. For example, when the thing move, it will follow the thing. Okay, whatever the direction it is, it becomes something like this one. So what they do is that you if you check the shape of the entire thing, it look weird, right? So if you are, for example, somebody don't know what they are doing, you would ask yourself how the hell the guy come up with this shape? Why not another shape? How he knows that here supposed to be like this and how supposed to be here like that? In reality, what they do is that they design the thing. Okay, it means that they engrain. Okay, the profile. It means that, for example, they calculate their profile. This is for example their profile. Okay, they use a sine wave profile. Okay, the profile just now we discussed, and after that, for example, they draw the profile. Okay, and based on this profile, they draw the shape of the cam. So this is the way that they do it. Okay, and this is the reason they like the sine wave. So why they like the sine wave? This is a very good question. Why they like the sine wave? The reason that they love the sine wave, because the equation is much easier to manage. So for example, okay, so for example, in the previous ones, I told you that, for example, you can have something like a trapezoidal drive, and for example, in the trapezoidal drive, you can put a low pass filter, those kind of things, right? Although low pass filter is a simple solution, okay, but that one is good for somebody with a control background and, for example, have some sort of digital what they call it, for example, can do programming. Okay, but for some mechanical engineer, this one is difficult. And for example, just giving you a straightforward formula like this is much easier to manage. So this is the reason that they love to use this profile for designing cams. So if you are a mechanical engineer, I believe that this one it would be very useful to you. And okay, by the way, you may ask why they don't use for example, other profile. For example, why they use, for example, this one's even more difficult. For example, something with chair. So the good thing about, for example, if you ask why they don't use something simpler like, for example, T-curve is lower order. Okay. If you ask why they don't use something like higher order, like for example, jerk or snap, those is even more difficult to calculate. This one, it give you a good mixture. It is not very, it is smoother. It means that it is higher order, but at the same time also is very easy to calculate. I personally don't use this in life, okay, because I'm a control guy, right? So I'm a robotic guy, so I'm not using this one. Now, I have developed this one once in my life, okay, but in the real life I will never use this profile in particular, okay. Over the mechanical engineers lab. If you enjoyed this video, I'm very glad. I have more videos like this, so you can see. Actually, this one is a course, so you can see the previous videos. And in the next video, I will explain how we do the higher order version of this one. So this one is more useful, okay, in life. So yeah, so in the next video, I will discuss about this topic. So without further ado, take care and have a good day. Bye.